first of all, thank you very much for this opportunity to be part of this great event in Munich. We've been working on a solution by merging artificial intelligence and part of artificial intelligence, basically the optimization algorithm. Yeah. It would work much better with if I can control what's going on the screen, basically. Yeah. Just be patient a little bit.
Just press manually, maybe. Just one of them.
Yeah, one of them there.
Like, next one, please. Yeah.
There's a flash of brilliance.
Yes. Yes. So basically, this is optimization, and it's about decision making. So Entscheidungsproblem. It's a German for decision making, but it's common in mathematics to call it like that. I will explain you why just a little bit later. And it's about bringing this experience, like a scientific background, to Dynamo. So our team is basically like Swiss, Russian, German team. Patrick left already to Zurich. So Sebastian is from Weimar, Bauhaus University, and I'm Dimitri. Currently, I'm at ATH. So our background, like math, engineering, architecture, and all of us kind of experienced in programming tools, and we do some also open source projects and writing some papers on the architecture and engineering across some conferences. Yes, it's still not working. Next, please. Next one. Yeah. So we've been discussing today that the people won't understand English or German, or like why is Entscheidungsproblem is German, why it's about decision, and it's about fitness, and it's about computation, like how many sit-ups it's possible to do, and we call it Monroe. It's model-based objective node gradient-based function optimization engineering. So we're not developing something new, but we're bringing it to the engineering context, basically. This was about like some talks were about if we should be worried about artificial intelligence. No, if you know the evidence, and this is basically around the topics. So yesterday, the lecture by Matt inspired us a lot by bringing this how you can understand knowledge and inspire basically tools we use every day with this knowledge-based tooling making of tools. We are bringing a little bit new perspective on that. So it's about like what is the design process? It's about not just knowledge. It's about collaboration. It's about decision making. And the design process is about ordering things and about decision making. Again, so it's these two things, like decision and order. So you see on there, like in the red state, it's about ordering stuff and decision making. The people made the decision as a part. So we nowadays as we been watching on a MED presentation yesterday, we can do this with algorithms, with optimization algorithms, with ordering algorithms. So, and basically there are three major algorithmic notions we do have in mathematics, in computer science, about how we do order. So we're ordering with meta-heuristics, is tools like generative algorithm. We have a direct search algorithm, which we're using in topological optimization. And what we have quite recently, we got like in the last 30 years, it's about model-based optimization tools. So if we look on the diagrams, how often we use generic algorithms. So we got like the major applications which is in use nowadays is the generic algorithmic tools. Then direct search, and just like few of them are based on a module-based optimization. And this is research which I was a part last year from Singapore, from Thomas Wortmann. He was trying to apply on different problems, different algorithms, and he figured out that generic algorithms actually they're the worst in finding the solutions. So if you're using that, just think about that. You could be much more efficient if you're applying different type of algorithms. Now, basically, how we started, we for existing library for Dynamo, which is based on generic algorithm, which calls Optimo. And we took a part of the research which was done at by IBM researcher Giacomo Nacini, which was a part of research at the IDC. It's a project between MIT and SUTD in Singapore. There are just like few major functions how the library is structured. I won't go into detail. But what is about? What's these 2 days is about? Is so basically it works in Python, and it uses libraries like NumPy, SciPy, PyOmor. It's was an optimization library, which was originally made by NASA. And you can't do this in the context of Dynamo, of .NET environment. So how we bridge that? Basically, this is part of code. So we're talking actually to the shell, to the Python shell. We executing it's kind of like a peer-to-peer.
It's a bootstrap.
Bootstrap, yes.
Pulling it up.
Thank you, man. But it's not really enough like just to merge all these things and to allow just to use a new type of algorithm or with a new efficiency. So we thought about like how we really make decisions and how to make really different tool what we are using nowadays. And if we look back to the mathematics, so we have this decision-making problem, Entscheidungsproblem. It's about to say with some mathematical rules what is false and what is true, but it's unsolvable. But in computer science, we have like kind of multi-criteria decision analysis. It's about multi-objective algorithm, and it works quite hard. So maybe Sebastian is willing to talk to you. He was basically in charge for solving this, for applying this stuff to our hacking.
Okay, hi. So we just heard that we have different algorithms to solve different problems. And in order to decide which one is the best, we came up with the idea to use a multiple criteria decision analysis. So to explain it in a nutshell, we give it a goal, and we have the different algorithms with the different priorities, and like after that we weight the different approaches, and then we build a overall hierarchy, and so we get the optimum or the different optimal solutions. So here we analyzed how it could look like. So we set the goal, we have the different approaches with the different algorithms, and if we reach this line, it's a so-called Pareto frontier, one algorithm will get switched off and it will continue with the more successful one.
So this is about exploration space. So then we have basically a matrix of solutions, which we then could observe in detail and pick one of them. Basically, all of them are kind of like optimum for this or that problem, and could even like pick the problem as we usually do this in the normal practice. So we have still, as a human, an opportunity of multiple solutions which are fitted to the optimum. Yeah, thank you very much.
So, okay, so from what I'm understanding, you basically can feed in some functional requirements, and then it's sort of a meta algorithm, like where it'll try multiple methods to solve for the same objective function. Is that kind of summary of what?
Yes, basically, so we are bridging this this gap between single objective optimization and multiple objective optimization. This is about like decisions, and this is about also about a decision like what algorithm we could apply on what solution. So if we do energy optimization, but also structural design optimization, so we need two types of algorithms. And this is to pick the right algorithm to do some job. It's kind of like to hire a right person to do the design job in an office.
Sure.
I have another question, and it is about the evaluation process, because if you like run an algorithm that goes, for example, against like genetic algorithms, you will have to evaluate. And how do you okay, you can do this definitely very well with, let's say, structural things, or like with usually physical approaches, but have you experienced like the same kind of algorithms with, for example, like conceptual designing things, and the other thing which comes because of this, how do you like set up the let's say how to prioritize one algorithm over another?
Okay, this is actually what it's about. This is what we call like research, right? To how to solve this decision-making problem. But basically, like how it works, like just in very basic things. So we have two kind of landscapes. So model-based optimization landscapes are just think in the terms of like 2D space, right? And it's basically like merging. It's how our architects are using this transparent paper, right? To basically to look on the plane behind. So this is kind of putting two landscapes. But then you're reaching basically like multiple dimensional space, and this is kind of the tricky part, how to deal with that. It's not really solved, so we're kind of we're just like playing kind of. Okay, this is a target, but yeah.
If we go a little further in the presentation, there were like this model with different shapes. you're trying to optimize, so I get the idea of you using different algorithms to optimize, for decision making, right? So are you optimizing like the space? Are you optimizing the shape of the building?
Okay, like this one is it was about just kind of to pretend to optimize, let's say like something like daylight simulation
So
and the distribution of space, or like how you put the neighbors, like just you can imagine that each of that solution is a house.
right, but the idea is, do you have like a general set of algorithms that you kind of adjust to the task, or every time you have like different tasks, space optimization or sun exposure optimization, do you change the algorithms, or it's always
Yeah, this you're talking about the objectives. So like space optimization is objective number one, like daylight simulation, daylight reduction or acceleration is like objective number two, and so on.